Hello all, I am Jairam. In a series of providing video sessions on C programming language. In my previous session, I have discussed about what are the different type of operations we can perform on files. What are the different type of operation we can perform on files? So these are the topics I have discussed in my previous session. If you want that session, please subscribe my channel Jairam Turlapati and like my videos and encourage me to do more videos. Now in this session I am going to discuss about what is meant by typecasting, how the compiler will perform typecasting, how many types of typecastings are there. So these are the topics I am going to discuss in this session. First of all, before going to discuss about the types, let's understand the definition of typecasting. What is meant by typecasting? So we have variables in a C program language, so we have different types of data types to also existed to come up with that variables. So if you want to convert variables of one data type into variables of another data type, then typecasting conversion came into existence in C programming language. That means there is a need in the program to convert the data types of that means variables of data type of one type into variables of data type another type. That's why typecasting concept came into existence here. That is the most important concept in the C programming language. Here I have written a program here. First of all, before going to that program, I have written point here. Understand the point here. If you want to store a long value, suppose I want to store a long value into an integer, then you can typecast long to int. That means if you want to store a long data type value into integer value, that means you have to convert. I am going to store long data type value into integer type. So there is a necessity for the programmer to convert their data types, because their data types are not equal, they are different. One is of type long type and another is of type integer type. That's why there is a typecast data types in order to understand the compiler and run the program and run the program correctly. You want to typecast it. Here this is the syntax, type name, and next one is that this is the expression. Type name specifies the data type and expression specifies how you can convert that variable. Next, here I have written a small program on typecasting. First of all, let's understand the program. Here I have included two header files, basic header files, std.h and conio.h. Next, here I have written a main method of type void type. Next, here I have taken some and value assigned 10 to it, 17 to it, of type integer type, sum of integer type, and assigned 17 value to it. Next, I have taken count value equal to 5. Next, double mean. Here in this example, the sum and count of type is integer type, where this mean type is double. That means here the mean of double type is going to store the result of the integer type. That means here sum and count. Here I am perform the division operation. The resultant value, this is these two of type integer type, so that the result is going to be stored in this into mean type. So this mean is of double type. That means these integer values are going to store in double. That means both are different data types, so we have to typecast those variables. That's why here I am using the double. I am putting double. This is the way called explicit typecasting. Why? Because here I am changing this integer data type to double data type in order to store the data in order to store the result in this double data. I am changing their data type to double, and this mean of type is double. That's why both are double. There is no error. We get no error. we get no error. That means typecasting here. By using this double operator here, I am typecasting. Their data. This mean value specifies double. This mean values of double type, and the sum is and count of type integer type. And by using this double value, I am converting them to integer and I am converting this integer also double type, and then store this value into mean type. This mean value is of type double type. That's why we get no error, and the compiler execute the program successfully without any error. So this is the by specifying the operator before that one data type. This is called explicitly typecasting. So next I am printing this main value onto my output screen. Just value of main is just I am printing that value onto my output screen. So after compilation execution, I have got this error. Why? Because by the point in here t.40, why we get a float value like this? Because here the value is of type double type. That's why I have get this output. So this is the smart program on typecasting. Next. So here we have to know the two different types of pointers. Here the division operator, here the double, that means here this is the explicit typecasting. This explicit typecasting has the highest precedence over the division. That's why first of all it convert the these integer types to double type, and then it do the operation of division. First it perform the explicit typecasting, next it perform the division. Next typecastings may be that means type conversions may be implicit or explicit. Implicit means implicit conversions can be done by the compiler automatically. For the explicit conversions, you have to use the operator like this. This is by using the operator before the statements, we is called explicit typecasting. That means we are calling the data type explicitly. That's why it is called explicit typecasting. Next, implicit typecasting means the compiler do automatically for the data types. Next, integer promotion. Next concept is integer promotion. What is meant by integer promotion? Here, integer promotion is the process by which values of integer type smaller than. Suppose in our program there are the integer values are there. Those values are smaller than int or unsigned int. Then the compiler first convert those values those values which are smaller than the int and unsigned integer type. Then convert those smaller values to int and unsigned int. First of all, compiler checks whether any values are smaller than int and unsigned int. Then it convert those int and unsigned values to the unsigned values to the smaller values. So those values are smaller than integer type and integer type. First it convert those values to unsigned int and integer type and unsigned integer type. Next, here I have written a program on intro on integer promotion. Let's understand the program. You can get point very clearly. Sorry. Here I have included two header files, basic header file stu.h and kone.h. Next, here I have taken main method of type void type. Next, here I have taken I of integer type, assign 17 value to it. Next, here I have taken a character. This is character value. This is integer value. How can you add both? One is of integer type, another is of character type. How can you add both? So for the C value, for this character C value, the compiler assign the ASCII value for that character. Here ASCII value, what is meant by ASCII? American Standard Code for Information Interchange. American Standard Code for Information Interchange. That is the meaning of ASCII. ASCII. ASCII, American Standard Code for Information Interchange. So these are the ASCII values. There are different types of ASCII values for the variables. That means there are different types of variables are there. That means different types of characters. So compiler automatically assigns ASCII values to the variables. Next, That's why here to compiler assigns some ASCII values to the C value. C for ASCII value for the C is 99 and 99 plus 17 is 116. That is the output. That is the output. The value of sum is, that is the output 116. Here what I have done here, what I have done from what the point here noted, what the point we get from the program is here in the integer promotion concept. The compiler first checks if any value is smaller than integer or unsigned integer. It then converts those values to integer type or unsigned integer type, then adds the sum value and printed the output and displays the output on the computer screen. So this is the concept of integer promotion. Next value. Next concept is usual arithmetic conversion. So usual arithmetic conversion is in the here in this concept, in this usual arithmetic conversion is implicitly performed to cache the common type. Why? Because in this usual arithmetic conversion, first the compiler promotes the integer promotion. That means it converts all the data types which are smaller than integer and integer type. Then is first done the integer promotion. Then checks the program. If still any values are there, if still have operands, if still it has operands of different data types, then it convert those data types, and if not, then it follow some hierarchy. So this is the hierarchy. First of all, integer, and it has the higher precedence of unsigned int, next one long int, next one unsigned long, next one long, next unsigned long, next one is the float, next one is the double, next one is the long double. This is the hierarchy. So compiler first check the integer promotion operation. If the integer promotion operation fails, then it convert the different data type. If not, then it follow the hierarchy. By using this hierarchy, it done the operation implicitly. That means here implicit conversion. It done implicitly conversion. So the usual arithmetic conversions are not performed on assignment operation on logical operators. Why? Because these are the operators. So these arithmetic conversions are not performed on those assignment operators and logical operators. Next, here let's understand a small program. Here I have written a small program on arithmetic conversion. Here I have included the two basic header files. Next, here I have taken a main method which is of type void type. Next, here I have taken I of integer type. Next, assign 17 value to it. Next, here I have taken C of character type. Next, assign character to it. Next, it first convert it in the last program. Here to it converts this ASCII value to a C value to ASCII, assign the ASCII value of 99 to C. Then it add both, that means 19 plus 17 116. Next is this sum of here, the sum is of type float. That's why the float value is converted. That's why we get the output as float value, that means 116.000. Why? Because the float value, the sum is of type is float. That's why we get the output as this 116.00. But as in the previous program here, the output value here, the sum is of type integer type. That's why we get just 116. But here in this program, the sum is of type float type. That's why here we get an output. Here I have written a point here. It is simple understand that first C gets the integer, but as the final value is the double. Usual arithmetic conversion applies and the compiler converts I and C float and adds them, yielding a float result. So first it converts the C value to assign ASCII value to C, and then add 17 to it and convert those values to double. And here the sum is and the sum is in the float type. That's why here convert those double type to float type and simply prints that sum to output screen. That's why here I get value of the sum is 116.00. So this is the small program on how the compiler perform usual arithmetic conversions. So this about the typecasting, how the compiler convert data type of one type to data type of another type, and how the compiler will convert, how the typecasting is done implicitly and explicitly. So implicitly it done for the implicit conversion, the compiler do automatic conversion. For the explicit conversion, you have to like this, you have to call that explicit operator, you have to call that conversion explicitly. So this is about the typecasting concept in the C programming language. So if you like this session, please subscribe my channel and like my channel for more videos. In this session I am going to discuss about header files and what is meant by preprocessor. So these are the concepts I am going to discuss in my next session. And thank you Vandal for watching, and thank you all.